Alright, so what I'm going to show you in this video is how to use the area model that we use to multiply two numbers to multiply two polynomials. So first, take a look at the number of terms that we have when we're multiplying each polynomial. So here we just have 8x squared, which is one term, and here we have 5x minus 3, which is a polynomial that has two terms. So when we create our box or our rectangle, we need one row and two columns. So our 8x squared will go here, and then our 5x minus 3, so each term will have its own place, will go here. So remember, we're thinking of this as finding an area of a rectangle that has this length and this width. So what we're going to do is we're going to find each one individual area. So 8x squared times 5x gives you 40x to the third, and then we're going to multiply 8x squared and negative 3, and that's going to give us negative 24x squared. And then we want to take a look to see if we have any like terms that could be combined together. In this case, we don't, because we have x to the third and x squared. So this is just our answer. So our answer is 40x to the third minus 24x squared. This is just another way to write the same expression. So these are two equivalent expressions that both would give us the same answer if we substitute in a specific x value. This is a factored form because we're multiplying, we're writing it as a product, and this is, I guess, multiplied out form, where we have everything just added or subtracted. So these are both equivalent, just two different ways to write it. Now here we have a binomial, because we have two terms here, that is multiplied by another binomial. So in this case, we need a rectangle that has two rows and two columns. So we have 4n minus 5 here, and then 6n minus 1 here. And then we're going to go through and multiply to find area of each individual rectangle. So 4n times 6n will give us 24n squared. 4n times negative 1 will give us negative 4n. Negative 5 times 6n will give us negative 30n. Negative 5 times negative 1 will give us positive 5. And then we're going to take a look to see if we have any like terms. What we notice here is that we do have two like terms, and they are diagonal from each other. So I can combine them. Negative 30n and negative 4n will give me negative 34n. Remember that when we combine like terms, the actual variable and the exponent do not change. The only thing that changes is the coefficient. There are no other like terms, so now we can just write our answer. Usually we write the answer for polynomials in descending order, meaning that the highest exponent comes first. So it's a good idea to get used to writing it from this corner, sort of this way. So that way your highest exponent is going to be first. So 24n squared minus 34n plus 5. So this is my factored form on the left, and this is my multiplied out form on the right side. Okay, so very similar, we have a binomial times a binomial, so I need a 2 by 2 rectangle. And I'm going to set this up, so 5n plus 4 times 5n minus 4, and we're going to multiply this out. 5n times 5n gives us 25n squared, negative 20n, 20n, and negative 16. Usually we have like terms diagonally, so we take a look, and we notice that they actually would cancel out because we have a positive 20n and negative 20n. So this is actually just going to go away, so there are no n terms. So the only thing we have is 25n squared minus 16. And this is going to be, it's called the special product. So difference, it's a difference of two perfect squares. But every time you have the same first term and the second term, where in one factor we have a plus and in another one we have a minus, every single time we see this, our middle terms will always cancel out. So if you have 2n plus 3 and 2n minus 3. So you have to have the same first and last term and opposite signs. So when we multiply this out, our two middle terms will always cancel out, and you would just have 4n squared minus 9 as your answer. But we'll come back to this. I just wanted to point this out. Something like this. So I just want to first show you what not to do, and please be careful, do not do this. A lot of students think that they can just distribute the square and square each part, and I see answers like this. This is not correct. Please don't ever do this, and I'm going to show you why this is not correct. So thinking back to our exponents, remember that squared means that we're multiplying ab minus 8 by itself twice. And then what I'm going to do here is I'm going to set up a rectangle so that we can multiply it using an area model. So ab minus 8, another ab minus 8, and we multiply each one. Negative 16b, just kidding, because 8 times 8 is 64. 64b, negative 64b, and positive 64. So we do have like terms, they don't cancel out because they're both negative. We get here negative 128b. And this is the term. This is going to be the term that you would be missing if you do this incorrectly. You're completely losing the middle term that will have b's. So the actual correct answer here, and I want to make sure we don't have the wrong answer on our board here, is going to be 64b squared minus 128b plus 64. Okay, so we just have a couple more examples. In this case, you are going to set up a rectangle that has 3 rows and 2 columns, or you can also do it the other way around. It doesn't really actually matter. So I'll do, actually it's a little easier doing it this way, so I'm going to do 3 columns. Okay, so I'm going to put my trinomial, which has 3 terms, on the top, and my binomial I'm going to put on the bottom. So I'm going to go through and multiply. I get 18m to the third, 15m squared, negative 3m. The nice thing about this area model is that you can really go in any order as long as you write your answer in the right place. So we'll look for like terms before we write our answer, and again they are diagonal from each other. So we have m squares here, and we also have m's here. So you have 30m minus 3m, which is 27m. We have 36 plus 15m squared, so they're going to be m squares. 36 plus 15 is going to give us 51. And then we're just going to write our answer. So we're going to start from the highest exponent, so we're going to go this way. 18m to the third plus 51m squared plus 27m minus 6. So these two are equivalent expressions. The left one is in factored form. The right one is in multiplied out form. Okay, so here's our last example. This is going to be as complicated as you can possibly make this. Of course, I can give you 5 by 5 terms, but I'm not going to do this. So I think this is plenty. So 3 by 3, this is going to be our biggest box that we'll make. So we have a trinomial times a trinomial. So we have 3 columns and 3 rows, which means we will get 9 terms when we multiply this all out. So we have 8p squared, 2p minus 2, 3p squared, 5p plus 2. Okay, we're going to carefully go through and multiply everything out. 6p to the third, negative 6p squared. 5 times 8 is 40, p to the third, 10p squared, negative 10p, 16p squared, 4p, minus 4. So what I'm going to do is go through and find all like terms. Again, diagonally is where we find them. So we have 4p minus 10p, which gives us negative 6p. We have p squares here. We have 16 plus 10 minus 6, which gives us 20 p squared. We also have p to the third. So 40 plus 6 gives us 46p to the third. And now we can write our answer. So I'm going to start with the highest exponent. So 24p to the fourth plus 46p to the third plus 20p squared minus 6p minus 4. So we can't combine any more of them, any more terms. They are all not like terms. We have p to the fourth, p to the third, p squared, p, and the number that has a degree 0 for the variable. And then this is your, on the left, your factored form of the expression, and on the right side, your multiplied add form. And this is going to be your final answer.